This video provides an overview of ship fore end structure, examining the construction and reinforcement necessary for maritime safety. The forward section of a vessel faces significant stresses from heavy seas, requiring robust structural design to withstand these harsh conditions. This elevation view illustrates the internal components of the fore end, including the chain locker, decks, and various support structures like breast hooks and stringers. An isometric view showing the layout of the fore end, highlighting key structural elements such as the collision bulkhead, panting beams, and stringers. The stem is the foremost part of the hull. Modern vessels often use a, quote, soft-nose stem design to buckle during a collision, minimizing impact damage. Structural integrity is maintained by welding the stem bar and using horizontal breast hooks between decks to reduce unsupported spans. These cross-sectional diagrams demonstrate how the solid round stem bar and breast hooks work together to provide necessary stiffness. The forward structure of a ship is specifically reinforced to withstand three primary challenges: pounding, panting, and collision. Pounding occurs when the vessel's bow is lifted and slammed into the sea. Strengthening the bottom structure in the forward area mitigates this risk. Regulations require additional stiffening in the pounding region, with specific spacing requirements for floors and girders depending on the framing system and operating draft. Panting is the in and out movement of hull plating due to pressure variations. To resist this, internal structural arrangements are installed within the forepeak. Further methods to resist panting include the use of side stringers and perforated flats, with specific requirements based on vessel size and frame configuration. These diagrams detail the arrangement of panting beams and perforated flats, showing how they connect to the ship's structure to provide support. A triangular stringer arrangement creates a rigid, closed shape at the fore end, effectively bracing the hull plating against deformation. In this final view, we see how all these components, including the chain locker and various structural supports, integrate to maintain the integrity of the fore end. This video now examines the function and construction of bulbous bows, a feature designed to enhance vessel efficiency. Bulbous bows are often integrated into modern ship designs to reduce wave-making resistance, effectively helping the vessel move through water more efficiently. By improving forward buoyancy, these structures also play a role in reducing the pitching motion of the ship during navigation. The design of a bulbous bow depends on the specific shape and size of the hull, often serving as a smooth continuation of the side shell. Construction includes internal framing with floors at every frame space and horizontal diaphragm plates, typically spaced no more than 1 meter apart. For larger bulbs, a centerline wash bulkhead is introduced for additional structural integrity, while smaller designs may only use a centerline web. Crucially, the shell plating covering the bulb is increased in thickness, particularly in areas vulnerable to damage from anchors or chains. This diagram illustrates the typical reinforcement patterns used within the bulb, ensuring the structure can withstand external pressures and operational wear. Beyond the bow, we must consider the hardware that facilitates anchoring, specifically the hawse pipe, spurling pipe, and the chain locker arrangements. The chain locker is strategically positioned forward of the collision bulkhead to store anchor cables safely while ensuring a direct lead to the hawse pipe. If a chain locker is located aft of the collision bulkhead, it must be watertight and equipped with dedicated drainage systems to prevent water ingress. Within the locker, port and starboard cables are stowed separately, with ends securely fastened to the structure to prevent movement during travel. Visualizing these internal chain arrangements highlights the complexity of managing heavy mooring equipment within the ship's confined forward spaces. Finally, we examine the construction details, such as the use of perforated plates to create a false bottom, allowing for easier cleaning and drainage. This concludes our overview of the ship's fore end structure, from its external reinforcement to the internal systems that ensure operational safety. This section covers the design of the chain locker. A centerline bulkhead is often installed to separate port and starboard compartments, allowing for working space above the chains. Inside the locker, footholes in the bulkhead allow access to the bottom. Careful design ensures no projections exist that could be damaged by the shifting chains. The upper edge of the bulkhead is typically stiffened to serve as a platform, and chain pipes are installed to feed cable from the deck to the compartments. These pipes, often called spurling pipes, feature specialized moldings at their ends to prevent chafing as the anchor cable passes through. Next, we examine hawse pipes. These are designed to provide a smooth, efficient lead for the anchor cable, from the windlass to the anchor. The pipes must be of sufficient thickness and shape to house the anchor securely, minimizing movement caused by wave action while the vessel is at sea. Reinforcement of the shell plating and surrounding framing is essential to support the weight and forces exerted through the hawse pipes. To prevent chafing, substantial lips are welded at the deck and shell interfaces. These are often either separate castings or part of an integrated structure. Finally, we look at bow thrust units, which provide essential maneuvering capabilities for modern ships, especially during close-quarters navigation.